Alright, so moving on to the next topic. First, we're going to look at figuring out how to calculate single doses of pediatric medications. So as far as rounding, a general rule is that most of it is rounded to the nearest tenths. A lot of times, if you're taking care of children, you can get doses that are rounded to the nearest hundreds. As far as as far as rounding rules go for this week, biggest things to remember that are new is that if you're giving 1 or more milligrams of a medication, it's going to be rounded to the nearest tenth. And if you're giving less than 1 milligram of a medication, it's going to be rounded to the nearest hundreds. That's like in week 2 when we said if we were giving more than 1 milliliter of a medication, it was to the nearest tenth, and less than 1 milliliter was to the nearest hundredth. So those are very similar there. Also remember that all heights and weights have to be rounded to the nearest tenth if your answer is going to be just the weight. So 2 biggest things to remember for this: 1 kilogram is 2.2 pounds and 1 kilogram is 1,000 grams. There is a worksheet posted in Canvas that is just a weight conversion refresher. So at this point, I paused the video, go work on that, check your answers, and make sure that you do have a good understanding of how to convert your weights before we move on. So a big important note to remember before all of this is to remember that you do not round the patient's weight before setting up the problem. And what I mean by that is if it says the child is 38 pounds, do not convert it to kilograms first and then start plugging it into your problem. It'll make more sense in a minute, but if you do that, then you're using a rounded weight to start with, which means then you'll get an incorrect amount of medication that you would give that child, because it's going to be based on that rounded weight and not their actual converted weight. So in that case, the answer would be wrong. All right, so looking at our first example here, these parents of this 2-year-old brought their kid into the ER because they have a fever. The provider wants them to get Tylenol. Ordered dose is 15 milligrams per kilogram, PO once. And available, we have an elixir of Tylenol that has a concentration of 160 milligrams over 5 milliliters, and the child weighs 38 pounds. So we want to know how many milligrams total the patient's going to receive and how many milliliters that we're going to give to fulfill that order. So our order, 15 milligrams per kilogram. Our child's weight was 38 pounds. And available is 160 milligrams per 5 milliliters. Okay. Now, you want to know how many milligrams the child's going to get. And we want to know how many milliliters that we're going to give this child. So starting with A, let's do our work here. Okay, so our work for A is going to be here. So we're going to start out with our dimensional analysis cross. So setup is the same for these. However, instead of the order going on the left, what we're going to put first is our child's weight. So we have 38 pounds. Now next, we're going to put our 1 kilogram is 2.2 pounds conversion factor. And reason we're doing this is because our weight is not given to us in kilograms. So we have 1 kilogram over 2.2 pounds. So remember, peds weight, actual patient weight first, then our conversion factor if we need it, and then we're going to put what our order is. So in this case, it is 15 milligrams over 1 kilogram, because this is saying that they're getting 15 milligrams per 1 kilogram. So at this point, pounds cancel out, kilograms cancel out. We're left with milligrams, which is what we need. So we can start multiplying across the top and the bottom. So we have 38 times 15. It's going to give us 570 divided by 2.2. And that is going to give us, in the calculator, it is 259.09090909, and so on. So remember, it's more than 1 milligram we're giving, so we're going to round this to the nearest tenth. So 259.1 milligrams is the dose that this child's receiving. So 259.1 milligrams. Okay. So now we're going to figure out how many milliliters we're going to give this child. So biggest thing to remember with these, because there are multiple steps with all of these problems, is that you're only going to use each piece of information once. So we've already used our order. We've already used our child's weight, so we're not going to use that again. So you're probably thinking, well, what the heck am I going to use as my order? If we already used the order, we're not going to use it again. You're going to use your answer from A to get your answer to B, because this 259.1 milligrams is our calculated how much the patient's going to receive. So dimensional analysis setup. So think of your answer for A as your new order. So we have 259.1 milligrams is our order. And now what we have available is 160 milligrams per 5 milliliters. So we're going to set that up on our right-hand side like we normally would. So our milligrams is going to cross out. We're left with milliliters, which is what we need. So we can multiply across the top and the bottom. So we have 259.1 times 5 0.5, divide that by 160, and now on our calculator we get 8.096875. So our same rounding rules from week 2 for milliliters apply. We're giving more than 1 milliliter, so we're going to round to the nearest tenths, meaning that we are going to give this child 8.1 milliliters of Tylenol. And so there's our answers. We figured out that we're going to give our kid 259.1 milligrams, which is going to be 8.1 milliliters based on our available amount of Tylenol. All right, so moving on to another example of this. Now, the 7-year-old is brought into the emergency room by their parents. He's found to have a low heart rate. So the provider wants to give the child 0.02 milligrams per kilogram of atropine IV stat. We have a vial of atropine that has a concentration of 8 milligrams per 20 milliliters, and our kid weighs 43 pounds. So again, we want to figure out how many milligrams we're going to give the patient and how many milliliters we're going to give them. All right, so here we have all of our information. Starting out our work again. Okay, this will be A. We'll do that in the pink. Let's change it. This will be B, and we'll do it in that blue purple color. All right, so first let's look. We're going to figure out how many milligrams we're going to give our patient. So remember, with these, our child's weight goes first, so our kid weighs 43 pounds. Our weight is not in kilograms, so we're going to have to add in our 1 kilogram equals 2.2 pound conversion, and then we can go with our order. So in this case, 0.02 milligrams per 1 kilogram. So pounds cancel out, kilograms cancel out, and we're left with milligrams. So we can start multiplying across the top and the bottom because milligrams is what our answer needs to be. So 43 times 0.02 divided by 2.2. So we're going to get 0.86 divided by 2.2 is going to give us 0.39090909, and so on. So remember, it's less than 1 milliliter or 1 milligram of a medication that we're giving. So we're going to round to the nearest hundredths. So we have 0.39 milligrams as our answer. At this point, you should be realizing on how what I said in week 1, that this class builds on itself week by week. So by peds, we're using a little bit of everything from the other weeks. So we have 0.9 milligrams is 0.39 milligrams is what we're going to give this child. All right, so remember I said we're going to use everything once. So we've used our order, used our weight, so all we have left is what we have available and our answer from A. So A is going to help answer B in this case. So this 0.39 milligrams is going to become our order. So B is asking us how many milliliters we want to give. So we have our 0.39 milligrams here. And we have 8 milligrams per 20 milliliters available. So set that up. Milligrams are going to cross out. We're left with milliliters, which is what we need. So we can multiply across the top and the bottom. Which is going to give us 0.39 times 20 divided by 8. So 0.39 times 20 will give us 7.8 divided by 8, which is going to give us 0.975 on the calculator. We're giving less than 1 milliliter, so we're going to round to the nearest hundred. So in this case, it would be 0.98 milliliters that we're giving this child. All right, and that's how we figure out our single pediatric doses.